Hi everyone, so this is going to be a two-part video. It is all considered lesson one, but we're going over negative exponents and rational exponents. This is part one. This will be regarding rational exponents and radical form. Part two, we'll go over negative exponents. So I will link the video in this video for negative exponents. Most important part is to understand what a radical is made out of and what each part of the radical means. So what I'm highlighting in green is the radical sign. The number or the term that's underneath is considered the radicand. And this little number on the outside is called the index, and it's also known as the root. So in this case, this is the cube root, because it's a 3, of 27. When you don't see a number on the outside where the index would be, it's square root and it's really a 2. So you just got to make sure that you understand when you don't see a number on the outside, that is a square root sign, and that number is 2, but we assume it's 2 and it's not written. Just like when I have x, I know that the coefficient is 1 and the exponent's 1, but we don't have to write them. It's an assumed 1. So it's important to understand where you're looking in the radical and what each part of the radical means before we even start anything else. Okay, so you have your radical symbol, your radicand, which is what's underneath the radical, your index, which is your root, and the whole thing is considered the radical. So now if I have a base, our base is 81 raised to an exponent that's a fraction, we call it power over root. So power represents the numerator, root represents the denominator. So sometimes what you're going to have to do is you're going to have to change this type of expression into a radical. So I would put my radical symbol, 81 goes underneath, and since it's power over root, the power represents the exponent on 81, and the root represents the index, which is 2, which remember we don't write. And we also don't need the exponent of 1. So it's just the square root of 81. So basically the numerator of the fraction in the exponent in this expression becomes the exponent when you put it into radical form. And the root, which is the denominator, becomes the root of the radical. So the numerator becomes the exponent, the denominator becomes the root index. We can call it index, we can call it root, either one, or root index. So let's try a few examples. This is also helpful to remember it. You could think of it as power over root and relate it to power lines, which are high up, right? They're in the air, and roots of trees are below the ground. So you could think of power over root. Sometimes we say power, people high in power, they're high up in power. So that's the numerator, and then roots are underground, so that is the denominator. All right, so we're going to try a few examples. So we're going to, for the first 6 questions, change these into radical form. And for the second 6 questions, we're going to change them or rewrite them with a rational exponent. So for the first one, I see that I have 7 to the 1/2, and I know that the 1 represents the power, and the 2 represents the root. Okay, so now that I have that, I want to write my radical. I know 7 is my base, that's going to go underneath. The power is the exponent on 7. So the 1 goes as the exponent on 7. The root, which is the denominator, is the root that is outside of the radical. The only thing, when I have square root, I don't write the 2, and I also don't need to write the exponent of 1. So this is just the square root of 7. Number 2, same thing. You have your radical, 4 goes underneath, power is 4, that's going to be the exponent on 4, the root is 3. I keep that because that's cube root. When I have square root, like I did in question 1, I don't need the 2 on the outside, so I don't write it there. But if it's any other root besides square root, you have to actually keep the number that is in the spot where the index should be. Next one, we have 2 to the 5 over 3. That would turn into radical 2 to the 5th, and the root is 3. So cube root of 2 to the 5th. You can kind of think about it like you're working backwards. So the first number you're going to be writing on the outside is the denominator, and then the second number you're writing on the inside is the numerator. So let's try it like that for the next one. I'm going to make this 7. 3 is going to be the root. 4 is going to be the exponent because you're working backwards. This one would be the square root of 6 to the 3rd. So notice how I'm writing the square on the outside just to get used to where the numbers go, but when you're doing square root, you do not need the 2, so this is just square root of 6 to the 3rd, and we assume the 2 that goes here as the root. Last one, this would be radical 2, and it's to the first power, which again, we don't need because there's always an assumed power of 1, and the root would be 6. All right, now we're working backwards. We're doing the same thing, but now we're given a radical and we want to write it with a rational exponent. So you have to know if you don't see a number where the index should be, it's really a 2. So this would turn into 10 to the power over root, so 3 over 2. Notice how this exponent's on the outside. It's the same thing as if I were to say radical 10 to the 3rd. You can write it on the outside or inside. The only time it's going to change is when you have, if you have a coefficient and a few exponents, but we'll get into that later. Next one, exponent is really 1. We assume a 1. Power over root would be 1 over 6. Fourth root of 2 to the 5th would become 2 to the 5 over 4. So you can also think you're working backwards here too. The first number you're going to write down is the exponent. The denominator is going to be the root. So you're working backwards, just like we were working backwards, but also kind of upside down in the previous examples. This one would be the 5th root of 5 to the 5 over 4 power. This one we assume an exponent of 1, so this is 2 to the power over root, 1 over 3. And last but not least, we assume a 1 again, so this is 10 to the 1 over 6. All right, now we're going to do a few challenging examples that are from old Regents exams. So this question says, explain how 3 to the 1/5 to the 2nd power can be written as the 5th root of 9. So they just basically want you to convert this to a radical, right? They want you to turn this into a radical because that's what they're asking you to prove. So your first step would be, this is power rule. An exponent raised to another exponent, you multiply them. So 3 to the 1/5 raised to the 2nd power would become 3 to the 1 over 5 times 2 is 2 over 5. Now, if I'm given this, I want to change that to a radical. Remember, work upside down if you want to think about it that way, but power over root. The root is 5, the power is 2. And I can simplify that because I can actually figure out that 3 to the 2nd is 9. And you just proved your answer. This one, it says explain. If they say explain, you would have to actually write a sentence about how you did your work. So you would explain, I used the power rule. I simplified it to an exponent of 2 over 5. And then I converted it into radical form. And I figured out that 3 squared was 9, which gave me the 5th root of 9. The next one, it says given equal terms. So these are equal. So that's exactly what we're going to do. We're going to set them equal. Given equal terms, the cube root of x to the fifth equals y to the 5 over 6. Determine and state y in terms of x. That means you're solving for y. So these are in two different formats. One's a radical, one is a rational exponent. The easiest thing to do would be to change them both into rational exponents, which obviously this one already is. So if I change the first radical into a rational exponent, I would get x to the power over root 5 over 3 equals y to the 5 over 6. Now I have a little issue here because I got to solve for y. To get rid of the exponent, you raise it to the reciprocal. You raise it to the 6 over 5. And if you're doing it to that side, you have to balance out the equation and raise it to the other side. So what's going to happen is if I was to multiply these two, I would get 30 over 30, which is 1. So technically they cancel, and that would be y equals 5 over 3 times 6 over 5 gives you x to the 30 over 15, which you can then actually simplify to be x to the second. So y is equal to x to the second. And last but not least, they say write the cube root of x times the square root of x as a single term with a rational exponent. So I cannot multiply these two because they're different roots. I would have to change them into rational exponents. This one would become power over root, would be 1 over 3. This one, power is 1, the root is 2, so x to the 1/2. Now that they have the same base, I can multiply. And when I multiply two terms, I add the exponents. When you add the exponents, 1 over 3 plus 1 over 2, you would have to get a common denominator by multiplying by 2 and 3 to get a common denominator of 6. So that would turn into 2 over 6 plus 3 over 6, which is 5 over 6. So that's your exponent, x to the 5 over 6. And it says write it with a rational exponent, so that's exactly how we're going to keep it.